Large language models operate with knowledge cutoffs, can produce hallucinations, and lack inherent access to private, proprietary datasets. This split-screen diagram shows the architectural fix, Retrieval-Augmented Generation, or RAG. It transforms the model into a reasoning engine that retrieves real-time, verifiable context from an external database before generating a response. Grounding AI in this verifiable context reduces its reliance on static training data, creating a pathway for safer, more accurate enterprise deployments. This 5-step RAG pipeline converts a query into an embedding for vector database retrieval. The retrieved data augments the prompt to generate an answer. But in production, poor document chunking or irrelevant retrieval causes the model to generate a flawed response. When a RAG system fails, it is typically a failure of the data infrastructure, not the language model itself. To solve these retrieval errors, modern systems have moved toward modular architectures that can evaluate and critique their own performance. This loop shows self-RAG. The model decides if it needs external data and grades relevance, reducing retrieval failure by 67%. Corrective RAG adds an evaluator gate. It discards low-quality retrieved documents and forces a web search fallback for better evidence. For deeper reasoning, Agentic RAG and GraphRAG use autonomous agents to navigate complex relationships between entities, allowing for multi-hop retrieval across connected data repositories. These advanced frameworks shift the paradigm from simple text injection to the autonomous evaluation of context quality before any text is generated. Large language models store information in static weights. To keep responses current without constant, expensive retraining, engineers separate the knowledge base from the reasoning engine. This matrix shows where each tool fits. Prompt engineering is for rapid agility and formatting. Fine-tuning adjusts the model's tone or specialized behavior. RAG is the architecture used for factual accuracy and proprietary data access. Selecting the right architecture for the problem prevents technical debt. RAG remains the standard for verifiable, source-grounded knowledge retrieval. In sectors like law, medicine, or finance, the added latency of advanced RAG is a necessary trade-off for the strict factual grounding required for high-stakes applications. If your RAG system is currently failing, look first at your ingestion, chunking, and retrieval pipelines, rather than attempting to swap out the language model. RAG is a continuous data infrastructure capability. Its success ultimately depends on the ongoing evaluation of how effectively your data is retrieved and presented to the model.